Hi, Bayesians. In the last video, we plotted the relationship between age at marriage and divorce rate and the model outcomes of that. You can see that plot here on the right. In this video, I want to do the exact same thing, but I will do it using a different approach just to show you how we get to this answer. In this approach, I'll use ggplot, and we'll also use the functions in tidyverse. If you do not use this already or don't want to use it, then you don't need to watch this video. But this is for anyone who wants to, is comfortable in this language. You can also make the same plot with a slightly different coding environment. What we need for this plot, as before, is we need our fitted model, which is model 5.3 again. And we need these posterior samples and also the values that we're going to set to solve these equations. I'm just going to take those posterior samples as they were before. I'll rerun it, but you don't have to rerun it. And those posteriors, remember, give us 10,000 estimates in which the values of these estimates are in relation to their probability. So there aren't many estimates of alpha being 1,000. There's none. Most of the estimates are bound between, say, negative 0.3 and 0.3, and there'll be lots of values within wherever that is, close to zero, I suppose. And what we want to do, our challenge, is to simulate some data or create a data grid and then solve this equation, A plus BM plus BA, multiplying that by the data, and then plot the lines. A lot of steps there, but what we're going to do is the exact same thing that you do above using this link function and these base plot codes. So with tidyverse installed and loaded, and I've got my posteriors. Let me just create some space so you can see things. Got the posteriors here, and I'm going to make them into a data frame or a tibble. Either one of these works. Just kind of helps view them down here on the bottom. Okay, and then what you can do is kind of watch the bottom here. So what we want to do is take this posterior, and I want to do one thing to it first. I want to add see that row name on the left, 1, 2, 3, 4, 5, 6, 7. I want to make that a column. And really those rows, we'll call them iterations. So if I do something like that, 1 colon n row parentheses dot, it's just going to create a column down there. And that goes from 1 to 10,000. So that's my way of realizing when I solve this equation at different values of A, that I've got those solutions per iteration, because each line in this graph on the right is one iteration. In the previous step, we plotted 50 of those iterations, for example. So now I'm gonna run through this quickly for one value of A. Let's say that we set A, the value of age at marriage, to negative 1.2, let's say. If I run that, then it creates values of negative 1.2. And let's create a value of M equal to 0, which is the average marriage rate. Creates another column. And then all I'm going to do here is solve my equation. What is the equation? It's written right up here for us in our linear model. Because I've called these columns all the same thing, I can just paste that. Sorry. And that will give me mu. And what this mu is it's 10,000 estimates of the value of divorce in a state where the age at marriage is negative 1.2, and it doesn't matter if we have data there, we now have a model to predict that, and a state in which the marriage rate is at its average. Okay, and what I really want to do is I want to do this twice. I want to do it once for one value of age and another time for a value of age, and then connect those lines. And to do that, I'm going to use a little trick here. You remember above we had this a seek, and it's -2 and 3, and I'm going to take a seek and use this function called expand grid, and create a new variable called a that contains the two values we put up there for a seek, -2 and 3. That is the starting and ending points of these lines. And notice what happened here. I'm solving this equation for this first iteration twice. Once for when a equals -2, and another time for when it equals 3. Okay, and then if I add on the 0 for m, and then solve that mu, I now have the values at each iteration. In other words, what I'm going to do now is plot when a equals -2, I'll put a dot up at mu of 1.28, somewhere up there. And when a equals 3, I'll put a dot at -2.6, somewhere down there. And that's one iteration. One iteration usually isn't helpful. We need hundreds or thousands to really see a pattern. And so we'll do that again for the second iteration. Plot a dot, the start and the end, draw a line. Start and the end, draw a line. And if we do that enough times, the picture of the posterior distribution of this slope will come in view. Let me save this, because this is the, I'm going to call it like mu links. This is the exact same thing that the link function is doing for you. Okay, so let's check that. That looks good. I'm going to filter it so that I only have 50 iterations, because I don't want to plot 20,000 or 10,000 lines. So the first 50 iterations is what I've got here. Okay, and then I'm going to plot the dots first. So I'm going to go ggplot. The x is equal to the values of a, the y is equal to mu. Get my empty plot. This will show the dots. And if I want to connect those dots, I use a line. And the trick here is to group them by iteration. Let me just do it without the grouping first. So if I draw a line, it kind of looks like you might be happy about that line, but don't be excited about it, because that's one line. You notice it's connecting all the dots. What we want is a unique line connecting these pairs of dots. And we have to tell it what the pairs are, what the groups are. So we tell it the groups to connect are the iterations. And now I've got those exact same 50 lines that we had before. And because we don't really need the dots themselves are just for teaching how this works. We silence that. We have the exact same thing. We just took the dots off, and now we've got 50 plots of the relationship between divorce and age at marriage after accounting for marriage rate, what our posterior is. We can add the data in here. We want to give it a new data set to look in, which is called D. And in D, our Y is actually called divorce, right? But the X is the same. Okay, now we've created now in ggplot the exact same graph that we had created earlier. Here's the earlier plot. Make that 50 lines, first 50. And here is the same plot in ggplot. Any one of these works. These are fine. Use the plotting method that you would like. But these are just two ways of doing the same thing. So if you're good with that, you can end the video now. I'm going to do one more thing for a second. which is just show you there's no reason you have to set M to 0. What if we wanted to know the marriage rate when it's like at a pretty low marriage rate? What does this relationship look like? If I set M to -1 in the data file, I'm replacing, remember M was those columns zeros, now it's -1. And so now this effect of marriage comes into play. So when marriage is gets multiplied by its value here, when marriage is -1, the value of marriage in a state is -1, what's our implied divorce rate? What's the implied relationship between age and marriage and the divorce rate? And it's a little bit different, right? The dots stay the same because the dots are, we only have one set of dots, but this is now the implied relationship of age and divorce rate when there's a low marriage rate, right? And technically it's the same slope because we don't have an interaction here. But when we're making these plots, we usually put it at 0, but there's no law about that. If you want to analyze the relationship when there's like a low marriage rate or a high marriage rate or vice versa, you can do that. The second thing is, what if we wanted to see, instead of A versus the divorce rate, mu over here, if we wanted to see the impact, the relationship between marriage rate and divorce rate? And as you might expect, in that case, I'm just going to replace all the A's with M's. M-seek is from right up here. But I don't want to use zeros for M-seek because I now actually want to estimate it. So let me make M-seek a little different. I'll make it -2 and 3. I'm not sure if that's going to work, but we're going to figure it out. And then instead of making M0, I want to make A to A0. So that this is now the partial relationship between marriage and divorce when the age at marriage is at its average. I'll run it. The x-axis, I want M instead of A, but otherwise all that code stays the same. And this is one of the surprising results from the book, which is that the dots themselves look like a positive relationship, but after accounting for the age at marriage, there really is no remaining relationship between marriage on the x-axis and divorce on the y-axis. So that's the reason we need to run a model, right? Because if we only ran a single bivariate data plot, we'd get a different result. Okay, so that's how to plot the posterior with ggplot. Enjoy.